Hello students, welcome to Adantal. Good evening to all.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening. So let us discuss some more numerical problems.
सर जो लास्ट क्वेश्चन दिया था आपने उसका आंसर क्या था?
I don't remember the last question. Can you tell me something about that?
Yes, sir. Light from a point source in air falls on a spherical glass surface. Mu is equal to 1.5 and radius of curvature 20 centimeter.
What we have to find in that particular question?
Sir, image position of image
And what is your answer?
20 centimeters.
42.86.
No. Anyone else?
20 centimeters from the other pole.
From the?
From the
B
there are
dash.
two poles, not B dash.
No, but there will be only one. Na?
Spherical glass.
Sir, 100
Spherical
centimeter.
glass.
Sir, 100 centimeter.
Yeah, who is speaking 100 centimeter?
Sir, Kapil.
Yeah, very good. Let me discuss about that. So in that particular question, you are saying that u is minus 100,
Yes, sir.
r is plus 20.
Yes, sir.
Mu is 0.5, 1.5. Na? So the formula is minus mu1 by u. So please substitute the values.
So this week comes out to be 100. That's okay. But it has been given it's a spherical glass surface. Spherical मतलब sphere होगा पूरा.
No. Convex and concave are also spherical surfaces. Na?
Okay.
They are the part of spherical surface.
So unless and until we are given that's a sphere explicitly, we can't take it.
Yes, you cannot.
Okay. So spherical surface मतलब convex and concave. Single.
Yes, only one thing.
Okay. Thank you, sir.
Yes, 100.
Am I doing something wrong?
Sir, minus आना चाहिए 2.5 minus
1.
mu
So
equal
you-
to minus 100.
100. U is minus 100.
Okay, I forgot to put the minus there. Na? So it will be minus 1 by 100. Now it is okay.
Yes, sir.
B is equal to plus 100.
Yes, sir.
Try to get me the answer. Very good, Durga. because the angle with the plane is given, so angle with the normal is 60 degree, and it is given that it deviates by 15 degrees, so R is angle of reflection is 45, and this is other, this is AR, this is medium, and we have to get its refractive index mu. So according to Snell's law, mu is equal to sin I by sin R, sin 60 by sin 50, 45. Sin 60 is root 3 by 2. This is 1 by root 2. So root 3 into root 2 by 2. So 3 by 2 square root, 1.5 square root. Okay. So this is the refractive index, and you can in fact find the square root. Yes, Kapil, very good. And now we have to get the wavelength of the light. And refractive index can also be put in terms of wavelength of light. How can we do that? Mu can also be written as lambda AR by lambda medium. And we have to get lambda medium. That's what they are asking. Yes. So it will be lambda AR by mu. And what is mu? 1.5 square root lambda A is yes monoidal. What if I wonder? If you solve it, you will end up getting 3674 angstrom. D option. Please check everyone. Clear?
Yes, sir.
Yes, sir.
Basic question, but yet important. Utilizes your knowledge about the basics. Try to take only that much time as is required for the question. This is the main information. Yes, Mudra, very good. Because frequency does not change with change of medium. So frequency in medium 1 will also be same. Isn't it? Now in medium 1, wavelength is also known, frequency is also known, so we can get the velocity. After getting the velocity, we can get the effective index very easily. Lambda 1 mu is, so V1 is equal to mu lambda 1 . Two, na? There is something wrong.
Sir, actually, I have not calculated this process.
2 into 10 power 8. Yeah, now it's okay. Yes, what are you saying? So it is 1.5.
I did not calculate this problem in this process.
Okay, then how you are doing it?
1 mu 2 is equal to v1, मतलब कि velocity medium 1 by velocity medium 2, and velocity medium 1 is v, and
Yeah. That way also it is fine. So actually you are getting the relation between mu1 and mu2, and then you are
yes,
taking the
yes,
option.
yes, yes.
Yeah, that is also fine. That is also fine. But sometimes because you are getting the only ratio, not the exact values. Sometimes there may be two options with same ratio. For example, if I double the values, that mu1 to be 3 and mu2 to be 2.4, even then the ratio will remain same. Then this method will not work over there. Okay, so then you require the exact values.
Yes, sir.
So what you can do, at least calculate one exact value and then you can take the ratio. That will be the best way. Okay. So mu1 by mu2, it is v2 by v1, and v2 is 1.25 v1. 1.5. Now, is it 1.2 that we are getting?
Yes, sir.
Yes, sir.
So this is the proper method. Get one of the refractive index exactly, and then you can use their ratio. Is it clear? Why only getting the ratio? It is not useful because there may be two options. Suppose I make C option to be mu1 equal to 3 and mu2 equal to 2.4. So even then the ratio will remain same, just like this option. So that is not going to solve our purpose. Or even we may triple them, or even we may halve them. Whatever factor we can divide and multiply. Clear?
Yes, sir.
Next one. Light from a source. This is the diagram and the question. It means the reference medium is medium 1. They have compared the velocity of light in medium 2 and 3 with medium 1. I think this should be clear to you.
Yes, sir.
Yes, sir.
So
So
now,
we can add them. We can just add them and get correct relation between V2 and V3.
no, it's not like that. So now you have to go with Snell's law, na?
Yes, sir.
Because there will be two reflections. This is not direct one. See, I will make the final diagram. What is happening? This, na? This is the final diagram. Now I think it must be clear to you why you cannot go with that. Okay. So actually, what we will be doing is, for reflection at this boundary, I can write 2 mu3 to be mu3 by mu2, and it will be V2 by V3, isn't it?
Yes, sir.
This. So it means we are able to get mu3 by mu2 now. Let it be number 1. Now, according to Snell's law, when you write mu2 by mu3, it will be sin I by sin R1, na? And sin I is 5 by 6. Na? So it is sin I into mu3 by mu2, isn't it? So sin I will be 5 by 6. Mu3 by mu2 is 5 by. There is something wrong. Na? 1 minute. This is not mu2 by mu3, which is sin neither. This should be mu3 by mu2. Na? Yeah, now it is okay. So it should be mu2 by mu3. Na? So it will be 3 by 5. Na? So half. Na? So sin R1 is half. So R1 will be 30 degree. Na? So now we will go for another reflection and then we will get R2. That's how it will be done. So this shows R1 is clear.
Yes, sir.
Now similarly, what we can do is, mu1 by mu3 sin R1 by sin R2. We have to get R2, na? So sin R2 this was half, na? This is 4 by 3. So 2 by 3. Na? So R2 will be sin inverse 2 by 3. Na? C option. Na? Please check.
So what's the difference between increases by and increases to 25%? Can you please brief it? Just
Increases to, there is nothing like increases to 25%. Increases to may exact value बताएंगे.
Okay.
Increases by may they can give the reference of the earlier one.
Okay.
That it is increased by this much amount. For example, in your school times, your teacher used to use the word that your performance has increased by this much %. Okay.
Yes,
two includes the exact value, but by includes the earlier reference. That is the difference.
So if I say that it increases to 1% of gravity of
That will be grammatically wrong to say.
okay, right, okay.
Increases to it is just like what it becomes. You might have read the questions that where it is written that this value becomes double of the previous one, and that so increases to is like that.
Okay, sir, got it. Thanks.
Means wavelength of yellow light in the medium, in 2 mm thickness of the medium is 1800 more as compared to the wavelength in the air, in the equally thick air. It should be number of waves. Has 1800 more wavelength of yellow light. Yeah, that is also equally. Na? It means 1800 more waves are there. Na? Because one wavelength means one wave. This is one wavelength. Na? So such 1800 more cycles are there. This is the relation that they have given. So with the help of this, we can get lambda medium. And if we can get lambda medium, we can get the refractive index. Na? Because lambda is already known to us. So lambda medium or lambda x you can write. And here was so 1.54 is the answer. Please check everything. Little bit trickier, but good question.
Can you please repeat, sir?
I have calculated the number of waves as I have explained. Number of waves or number of wavelengths. One wavelength corresponds to this. Na?
Yes,
So
sir.
it is given that this medium and equal thickness of air. Read here. This. So it means thickness of air is also 2 mm. So I have calculated the number of wavelengths in 2 mm thickness. So one wave is having wavelength this much. Na? It is given. See. So how many waves are there? Thickness divided by wavelength of one wave. So this is the number of waves in air, and the number of waves in the medium will be 1800 more as compared to this. So I have added 1800. And similarly, also I can calculate the number of waves by this method. Na? Thickness
Yes,
plus lambda medium. And now I substituted this value over here, and I got lambda medium. And refractive index of the medium is what? Lambda
Yes.
air by lambda medium.
Yes, sir.
So can you go to previous slide once?
Yes.
Yes, sir. Thank you.
It's very easy. So only angle of emergence is given, nothing like R. But obviously angle of emergence is equal to angle of incidence, but R is missing. Na? And you are having this formula. So
Yes, sir. R आ जाएगा, sir.
what to do now? R तो आ जाएगा, but
Expand sin I by sin R. Sin A cos B.
yes.
Formula.
Otherwise, we put the Snell's law on the second face of the rectangle class.
Yes. Obviously you have to use that. Na? But only after getting R you can use that. Because you do not know the refractive index. The problem is this. That is the problem now. You have to get R only, then you can use that. Because mu and R both are missing. Or one more thing you can do is when you expand this, according to you, mu is equal to sine E by sine R. Na? Means sine I by sine R. Na? So it means sine R is sine I by mu. So that way you can convert R into I and mu if you want to get rid of this R. Is it clear or not? And cos R is 1 minus sine square R square root. Na? So it will be 1 minus sine square I by mu square. Na? So in place of cos R, you can substitute this. In place of sine R, you can substitute this. And obviously you will be getting terms containing sine R and cos R only. Na? Okay. So you can modify the formula actually. Let me do that. Sin I by sin R is 1 by mu. And we are left with cos I by cos R. Actually, I'm trying to get rid of that R. Now cos R is this, na? If I take the LCM, it will be like. So this is the formula that you can use in this particular question. Because you know T, you know I, and you know D. So then you can get mu. And this is also important. This can also be directly asked in the exam. Na? Okay. So now you can go ahead with this formula to get mu. And similarly, in some other question, you may be given R only, and then you can get rid of that I, and you can get everything in terms of R. What are the values? D is 8 centimeter, I is 30 degree. No, D is 1.8, na? And T is 8. This is 30 degree. That's it. Na? 1 minus cos I. Mu square sine square 30 degree. Please check. So I can actually take this there. Na? We can actually square it up, na?
Yes, sir. That's better.
Because otherwise the calculation will be very, very complex. So what is this 0.3025? What is this quantity? Please tell me the value of mu square. So it will be 2 point something. Na?
2.72.
And what is the square root? It will be around
1.65.
1.65. Okay. It means B option. And you can see even a simple question, it can become trickier. No?
Yes, sir.
Formula was very simple, but according to the given information, it became a little bit difficult. Clear?
Yes, sir.
Yes, any doubt to anyone?
Interested.
What? Actually, you are not audible. I don't know why.
Sir, previous slide.
Okay, thank you. But why there was so much disturbance on my side? I was not able to hear. Yeah, even now, I don't know what is happening. But Rita was very much clear. There was nothing like that noise.
Then, sir.
Okay, thank you. I think he might be using earphones. It is because of that sometimes.
Sir, I also use earphone.
But when you speak, there is no disturbance. No? It is crystal clear.
Yes.
And here bubble is trapped inside a glass cube of h 30 centimeters. So this question is also very, very important. Now it is the case of double reflection. Looking through the face ABEH. Yeah, it may be. Normal distance. This is the question. Note it.
Yes, sir.
Now let us try to understand what they are saying. Let me make the cube first.
Sir, please answer the question, please.
Yes. Instead of glass slab, now they are saying glass cube. Now. So it has become a little bit difficult. Not so much, but some things we have to keep in mind.
Can we use the concept of real depth and apparent depth?
Yeah, that's what we will be using. But still, we have to be careful about the diagram and what is happening. Now. Actually, if you see carefully, your glass slab, it is cuboidal, and now they are giving a cube. That's what the difference is now. Isn't it? Glass slab is
Yes,
also cuboid now. So now they are making all the sides equal. Now see, let me make this cube first, then I will tell you what is happening. A, H, G, E, B, C, D, F. Okay. So
So the answer will be 1.5 refractive index.
1.5 refractive index. Yes, you are right. So what is happening? Light is falling on the first phase. So with respect to first phase, it is given that first of all, this is 30 centimeter. All the sides are 30 centimeter.
So actually, there are two methods. Very tricky method is as the cube is made of glass cube, so glass refractive index will be 1.5. And second one is the
But even glasses are of different kind. You might have read. Even glasses are of different kind. It varies from glass to glass. And in some numericals, you may even get 1.47, 1.48, 1.51. So then actually the actual position, it may vary. So we cannot take the risk that glass has refractive index 1.5, so it will be 1.5. Don't make this mistake in diagram. Here also I told you that in numerical, they can give you any value. You may even get 1.4. Then what you will do? So I don't recommend that assumption that it should be 1.5. Obviously, it is correct. Means in this particular numerical, we are getting that, but not in every numerical. And what is the other way?
then we get one side view 12 centimeter.
Yes.
It is apparent height. So we
Yes,
can
yes, you can get the real one.
then 30 minus x. If we take the position x from a
Yes.
side of the cube wall,
Yes.
then x by mu is equal to 8, and the second equation will be 30 minus x by mu equal to 12.
Actually, the sum of those two should be equal to means 20, na? Whatever way you take it. Because some of the students, they may be taking this distance from this face to be x. Let me make the diagram. It is going from rarer to denser, na? So it will be bending 1 minute towards the normal. So it means the ray is coming like, actually it is very difficult to make the diagram this way. So let us suppose the normal is this. So light was coming and it has went toward the normal and it falls here. Is it okay?
Yes.
This is first reflection. And let us take this distance to be x. And then this will be 30 minus x now because total is 30. Okay?
Yes.
And now what will happen? This will go there. This is the normal. So now it is going from denser to rarer and it will bend away from the normal like this and it appears to be here. This is the apparent one. This. Clear? Is the diagram clear?
Yes.
Let us denote this by x now. Apparent, no, not x, I'm already using P. Okay. So mu, it will be, actually there should be some point over here, no? Just below this one. I need to call this point as O. Let's call this O. P. This is I. This is Q. At this phase, this is Q. Okay. So OP, and then it should have gone here, no? Actually. Is it clear?
Sir, I is the final real image that is to be calculated.
Yes.
Okay.
Actually, it is other way around. No? This is let me call it O. That will be more convenient because the object is here. No? This is the apparent one. No? Let me read the code. This is the real one. Sorry, this apparent one is given from one phase. It is given to be 12. Yes. So you are let's call it P. So PO is the real one, no? Isn't it? And
Yes, sir.
this let's call this I1. This is I2. So mu will be real depth over apparent depth. No? And what is real depth? Real is a PO, no? That you are assuming, and apparent one is PI1. And PO you are assuming it to be X. No? Please check. And PI1 is given to be 12. No? So X by mu is 12. No? This is for refraction at phase 1. Now similarly, for refraction at phase 2, what will happen? Again, that same funda, mu is real depth over apparent depth. Now what is real depth? Real is QO, and apparent one is QI2, and QO is,
30 minus.
and this is given to be 8. No?
Yes, sir.
30 minus X by mu is 8. No? Now we can add them together and we can get rid of this. We can actually calculate this X by mu factor. No? Or yeah, we can get rid of that X by mu, and it means we can get that mu by solving this. And once you get the mu, you can get X and even 30 minus X. No? So now we can actually add 1 and 2. So adding 1 and 2 we get. So substituting the value of X in 1, mu in 1, sorry. It was 12, sorry. That's what I was thinking, that it is appearing to be at phase. So 18. It means it is 18 centimeter from phase 1 and 12 centimeter from phase 2. No? Please check everyone.
So can I go to the previous slide once?
Yes.
So for phase 2, light is coming out from the cube towards the edge. So
For
mu
both,
to
for both the phases, it is coming from within the cube, no? Because object lies within the cube.
okay. I was thinking the inverse of this. Okay.
So that's why I have represented I1 and I2 no? To be the actual apparent one, to be the apparent positions of the bubble from both the phases. I1 is from phase 1 and I2 is from phase 2. Okay.
Yes, sir. Got it. Thank you.
So there is a bird and a fish. But now it is a different problem. Earlier also we did one problem no? On a bird and fish, on the apparent height and depth. So now it is based on velocity. So I can help you with the diagram. So suppose it is a lake. So there is a fish. Again, it is very difficult for me to make this diagram. I hope it is fine. This is a fish. What is the depth of the fish? Okay, only velocity is given. So let it be x. Okay, and then there is a bird. No? Now how to make a bird? Let me try. I think it is okay. No? So let this be y. Now what is the question? Speed of both are given. No? Refractive index of water is given to be 4/3, and we have to find actual velocity. Okay, velocity of the bird with respect to fish is given. So we have to find the actual velocity of the dive of the bird. Okay, so to the fish, the bird will actually appear at a greater height. No? Isn't it? To the fish, the bird will appear over here. Am I right? Or not? This is the
Yes, sir.
apparent height of the bird with respect to fish. So let x be the depth of fish below the water surface, and y is the height of, this is at some time, okay, at some instant, because they are changing. Na? Fish is diving and the bird is also diving. Height of the bird above surface. Then apparent height of the bird it will be mu y. This will be the height of the bird that will appear to the fish. Na? This is outside. Na? Apparent height of the bird for the fish. So it will be mu y plus x. Na? Because fish is below the water surface. Na? So for the fish, the bird is actually at a height of x plus mu y. Okay. Let us take this to be h. So differentiate with respect to t, time. Differentiating with respect to time t we get. Plus dx by dt. Now dh by dt is given to be 9. Na? Because this is for the bird and this is given to be this c. And this is dx by dt. Na? Please check. And dy by dt we have to calculate the actual one. So 9 minus 3 is, mu is what? 4/3. Na? So 6 equal to, let me write on the next slide. Can I write here? Yes. 6. Then dy by dt will be 6 into 3/4. So 339/2. 4.5 meter per second. So this is the answer. Please check.
So can you explain why dh by dt is equal to 9?
This is the apparent height of the bird to the fish. Na? And now read the question.
Yes, sir.
Read the question. That the fish observes. Fish is observing the bird to be diving towards it at 9 meter per second. So the rate
Okay.
of dive of the bird with respect to fish is given. Na?
Yes, sir. Yes, sir. Okay.
That's why it should be dh by dt. And for the fish itself, it is 3. And this is the actual one. Na? Because y was the actual height of the bird. So actual dive rate will be dy by dt. Okay? Clear?
Yes, sir. Clear.
Done, everyone?
Yes, sir.
So that's all for today. Okay, students. Bye bye. Take care.
Thank you, sir.
Thank you.